Hi, this is Kevin, and welcome to part 3 of the tutorial that we're doing for chapter 3 of the Zelle Python book, 3rd edition. And in this case, we've already done a couple of integer arithmetic uh, examples, in particular integer division. Integer division can be tricky. Okay. In the other kind of division, it can be tricky in terms of what you're going to get is when you're mixing types. Okay, so the two types that we've learned about so far, the two numeric types that we've learned about so far, and we're going to be using for the really the bulk of the course, are int and float. I just want to point out while we're here that there are other numeric types. And one of the nice things about an object-oriented language is the ability of the user community or the Python infrastructure developers to think up new types and to implement them with classes. So the fact is, there is another type that we can use for these numbers that have decimal fractions. It's called decimal, and it's in a module called decimal. And it really does math kind of like the floats do, but with much more control over issues like rounding and how many digits of precision and all that kind of stuff. So um, we're not going to use it right now, but I just wanted to show it to you because I wanted you to know that there's more than ints and floats. And that the other thing is this is a very extensible language. These object-oriented languages where you can invent new types through defining classes are very powerful this way. Okay? But of course, when you're learning, you can only learn so much at one time. So we're learning how to use the basic numeric types int and float. And so unless you're working with division, you pretty much it's not too surprising what kind of results you get when you mix types. If you mix ints and floats in addition or subtraction, you get floats. Okay? Because it converts everything to the type that has more information, because the floats have the decimal place. If you do multiplication, you have the same thing. If you do multiplication with an int and a float, regardless of which side is the int and which side is the float, you're going to get a float. Okay. Now here on the division side, you get the same thing. If you have an int and a float, you'll get a float. Okay. And we're really doing this as a way to kind of underline in your mind the fact that mixed type division with a single slash leads to floats, and it also leads to plain old division the way we typically think of it, where we get fractional answers. So we get exact answers. We don't get 3 remainder 2. We get 3.66 blah blah blah. Okay. So that's why we're practicing this, just to give you some chance on mixed types in expressions. And to remind you that when you do mixed divisions, because you're going to get a float answer, you're going to get an exact answer. Okay? All right, let's do that. So we're going to have a weird name for this. We're going to create a new, sorry, let's highlight the name of the project and right click and say new Python file. And I'm going to call this left int mixed type divide and accumulate. Okay, so we're going to do kind of like what we just did in the last one. We did divisions, and then we accumulated the answers, right? So we did that. But here, instead of doing it with two ints, we're going to do it with mixed types. And when I say left int, I mean the int is going to be on the left. It's going to be the first thing that we do. All right, so how could I do this? Well, let me show you my comments from the top of my pre-baked version. Okay, and make it a little bigger. So my pre-baked version was done on a bigger monitor. Okay, so we've got the name of the file, which again is pretty hairy. Left int mixed type divide and accumulate. And I still have a pointer to the resource on the division terms. And what do we say here? Accumulate the quotients of 5 number pairs. So we're going to have that loop again. The first value entered, the dividend, should be an integer. The second value entered, the divisor, should be a float. Accumulate the quotients. Okay, so this is a lot like the thing we just did. Okay, I tell you what I'm going to do. I'm going to go and I'm going to open up quotient accumulator py, and I'm going to steal the code. Okay, that's what I'm going to do. I'm just going to take all this code and steal it. And now we're going to do something that I would call, it's been called a lot of things, but I call this cloning. This is where you take a program that's very similar to the program that you want, and so you make an exact copy of the original program, and then you go back and you make adjustments to get the new code that you want. Okay? Now, some of the tools that we use here are the tools that are used for refactoring. But if you read the refactoring experts, refactoring per se is when we revise our code using refactoring techniques, and we don't change its behavior. So we just want to improve its readability, improve its maintainability, all those kinds of things, but the behavior is going to remain the same. Well, we can use some of the same renaming tools and stuff in this case, but we are going to change the behavior. So this is how you take code and change it to make a related but not completely the same program. Okay, so let's look at the housekeeping. Do we want an accumulator? Yeah, we do. Do we want it equal to 0? Yeah, we do. Is it going to be, are we going to be accumulating, ints or floats? Well, when you do mixed arithmetic, you get floats. So let's take this accumulator and say that we want to accumulator equals 0.0. Okay, so that means the accumulator is going to be accumulating floats. Okay, did we have to do that? No, we didn't, but it's really good documentation. All right, now let's look at the main loop. We're going to do it 5 times. Okay, for I in range 1 comma 6. Again, you have to remember the second value is the first value that you don't want. So if you want 1 through 5, it says 1 comma 6. Don't complain to me, complain to the mothers and fathers of Python. Okay, so we have some helper text that we're printing. Now collecting integer pair. Well, it's not an integer pair anymore. So let's say mixed type pair. Mixed hyphen type pair. All right, that's a little more descriptive. So now we're going to get the user input. Okay, that's going to be pretty similar. Now, which one do we want to be the int? Okay, we want the left one to be the int, the first one. How do we know? Well, the name of the program is left int blah blah blah. Okay, so the first one's going to be an int. The dividend is an int. Please enter an integer for the dividend. Well, that looks like it's good. The divisor in this case, I guess, is going to be the float. Okay, so let's change it to please enter not n float, a float. Float for the divisor. Are we done? No, actually, when I did this in practice, I forgot to make the change I'm going to show you now. If we want to float, we have to remember to do the conversion with the method float, not the method int. Okay? So now we're going to do the processing. Do we want to do integer division? No, we don't. Okay? We want to do plain old division, which will do floating point division. Okay, so a single slash, not a double slash. Okay, print. The quotient is quotient. Will that work? Yeah, it's just the quotient now is going to be a float. It's going to be a number with a fractional part. Okay, and then we're going to do the accumulator. Okay, how's that going to work? Accumulator plus equal quotient. That still works. It's the same code, even though the variables in this case are pointing to floating point type values. The code's the same. And then we need to create the output. The accumulated sum of the quotients is accumulator. Again, that's going to work just fine. When it prints out a float, it's going to give us a decimal point. Okay, so we didn't really have to change that much from our last one. Okay, good. So I'm ready to test. All right, so let's test. It's right click, run left int mixed type blah blah, and let's look. Okay, now collecting mixed type pair 1. Please enter an integer for the dividend. So what were we typing? We were doing 7 divided by 3. Okay, so let's say please enter an integer for the dividend, 7. Okay, please enter a float for the divisor. So in this case, I'm going to say 3.0. Okay, that's pretty clear. So the quotient is 2 1/3. That's the repeating decimal fraction. Okay, now collecting mixed type pair 2. So I'm going to do the same one again. I'm going to do 7. That has to be an integer. Okay, please enter a float for the divisor. Okay, now you don't have to put the decimal fraction in when you are doing a conversion from a string to a float. So last time I did 3.0. This time I'm just going to say 3. And it worked fine. So the thing to remember here is when you're supposed to be entering a float, it will take it will take an integer value. It has no problem with that because it knows it's just going to create a zero fractional part. Okay, but when you're going the other way, it doesn't work. If it says it wants an integer and you give it a value with a decimal point and a decimal fraction, well, it doesn't know what to do with that, and so it blows up. So now we're getting down to number 3. So again, let's say 7. Okay, and I want to point that as long as you're putting in a float, you could say 3.000000000. It's pretty tolerant of a lot of decimal places. No problem there. And then 4, let's do even more decimal places. 3.0. Okay. It didn't like that. It went too far. I guess that was too big. Oh boy. All right. Let's do it again and not do quite so much clowning around. Okay, so I'm gonna say 7 divided by 3.0, 7 divided by 3, 7 divided by 3.0, 7 divided by 3, 7 divided by 3.0, and the answer is 11.66666666. Now, could we have rounded that? Yeah, we could have rounded that if we wanted to. I wanted us to experience the fact that we get these approximations of the numbers, and without explicit rounding, we can get some things that are pretty long, right? So that's fine. Okay, so the good case works. Let's test it where we accidentally it says give us an integer for the dividend, and we say 7.0. It's not going to like that. No, that blew up. And let's try to get another one where we say please enter an integer for the dividend, and we just want to be mean, we say hi mom, and that blows up too. So we're pretty well done. Okay, in this I really wanted to be an example of how sometimes the program that you want to create is very close to one that you already have. And with a little bit of care, you can, I would say, clone the old program into the new program. And you get the benefit of the fact that if the old program has been properly coded and properly tested, you get the benefit of starting out with reliable code. It doesn't do exactly what you want it to do, but it does something pretty close to it. So that's it. For the demonstration, yours is going to be very close to this. The right part is going to be an int. So instead of being left int mix type divide and accumulate, yours is going to be right int mix type divide and accumulate. So good luck with that, and I'll see you next time. Bye bye.